Something strange just happened near the sun. NASA's latest solar imaging feed caught it first. A bright, fast-moving object skimming the solar limb, flaring brighter than anything else in the frame. Within hours, astronomers confirmed what it was: 3I-Atlas, our first interstellar visitor since Oumuamua, and it just survived its closest pass to the sun. But what's puzzling isn't just that it made it through, it's how. No visible tail, a sharp metallic glint, and a brief directional shift that shouldn't have happened under natural forces alone. As the data poured in, one question echoed through observatories around the world. Was this simple outgassing or deliberate course correction? Tonight, we break down everything: what NASA really saw, what's speculation, and what it could mean as 3I-Atlas heads back toward the outer solar system. No panic, no hype, just the facts, frame by frame. This is your real-time report on the object that defied the sun.
Right now, 3I/Atlas is racing through the inner solar system at more than 170,000 kilometers per hour, tracing an orbit no other known object shares. After slipping behind the sun in mid-October, it reappeared briefly in NASA's SOHO and stereo coronagraphs, glowing faintly against a curtain of solar plasma. The images confirm one crucial fact: its orbit hasn't changed. No deviation toward Earth, no hidden turn, no propulsion signature that science can verify. For now, 3I/Atlas is following the path physics predicts. But even within that stability lies mystery. Its coma, the hazy cloud around its core, remains unusually small. Spectral readings show carbon dioxide outgassing nearly 8 times higher than water vapor, a ratio never seen in typical comets. And then there's the reflection, a brief flash that hinted at a rotating surface, not a diffuse one. Telescopes from Chile, Arizona, and South Korea all caught the same pulse within seconds of each other. Could it be crystalline ice, metallic reflection, or something else entirely? As of now, 3I/Atlas is less than 0.4 AU from the sun, closing fast. Every new image matters. Every pixel adds to the timeline of an object that's breaking the usual rules of cometary behavior. And in just days, it will face the sun head-on and either flare into brilliance or vanish completely.
As 3I-Atlas drew closer to the sun, something unusual began to happen. Between October 23rd and 27th, NASA's Solar Dynamics Observatory recorded 3 major coronal mass ejections, each one blasting outward in the exact sector of space that 3I-Atlas was moving through. To most observers, that could sound like coincidence, but here's what makes it strange. Each flare triggered a localized surge in solar wind density, and within hours, 3I-Atlas's brightness spiked by nearly 40%, a pattern that repeated twice more. In comet physics, that kind of synchronization is rare. Then came the heat data. Thermal mapping from the James Webb Space Telescope detected a pulsing infrared signature, a central hotspot that brightened and faded on a precise 72-hour rhythm. That's not normal for natural rotation or venting. It suggests either a repeating exposure cycle or internal activity we don't yet understand. Some scientists argue it's simply outgassing amplified by solar storms. Others point out that 3I-Atlas's nickel without iron spectral line, first detected weeks ago, doesn't match any known comet composition. Whatever the explanation, one thing is clear: the object's interaction with the sun isn't passive. It's responding, in light, in heat, and in movement. Now, as perihelion approaches, every instrument, from the Parker Solar Probe to ground-based coronagraphs, is watching. Because if that pattern continues during closest approach, we may be about to witness something no telescope has ever recorded before.
Over the past week, headlines have exploded with claims: alien ship, hidden maneuver, engine firing near the sun. But before we dive into speculation, let's separate what's confirmed from what's not. Fact: 3I-AATS's orbit remains stable. Every verified astrometric observation from NASA, ESA, and the Minor Planet Center shows no measurable deviation beyond normal cometary physics. Fact: the brightness variations are real. They've been logged independently by observatories across 5 continents. But brightness alone doesn't prove propulsion. It could result from dust jets, spin axis changes, or reflection geometry. Unverified, any claim of engine activity or intentional control. No credible agency has released telemetry suggesting thrust or communication signals. Speculation: the synchronized heat pulses and metal spectra. Intriguing, yes, but still under analysis. Those patterns could come from mineral outgassing or micrometeor impacts, not technology. And finally, context. In science, unexplained doesn't mean unnatural. It simply means the data isn't complete yet. What makes 3I-AATS so fascinating isn't proof of intelligence. It's how it keeps challenging the limits of what we expect from interstellar debris. So until the numbers say otherwise, we stay grounded in evidence. The sky is full of mysteries, but real discovery only happens when we question our own imagination first.
The next few days are critical. On October 29, 3I Atlas will reach perihelion, its closest point to the Sun, traveling faster than any known comet observed this year. This is the exact window when its true nature will reveal itself. If it's a standard interstellar comet, we should see a rapid brightening, the formation of an ion tail, and perhaps a brief flare as solar radiation peaks. If it's something else, the pattern could look very different. Controlled luminosity, stable temperature, or even complete optical silence. For observers on Earth, this period offers a rare chance to witness science in motion. After October 31, 3I Atlas should emerge from solar glare, visible low on the eastern horizon before dawn. Look for a faint greenish glow, possibly the result of cyanogen and diatomic carbon reflecting in sunlight. At the same time, scientists are watching for geomagnetic activity here on Earth, with solar flares and coronal mass ejections erupting along the same longitude. Energy from these events could interact with the comet's plasma trail, triggering auroras that stretch far beyond the poles. Whether you're tracking data, capturing sky images, or just looking up before sunrise, this is your moment to join the story. Because in the vast silence of space, even one small shift in light can change everything we think we know about the universe.
As 3I Atlas swings past the Sun and begins its long journey back into the dark, one truth remains: we're watching history unfold in real time. Every new observation, every piece of data brings us closer to understanding what this interstellar traveler really is. Whether it's a fragment of some ancient system, a frozen messenger from deep space, or something we've never seen before, its story is far from over. For the next several weeks, telescopes across the world will keep tracking it, measuring how it brightens, dims, and reacts to the solar wind. Amateur astronomers, maybe even you, can capture the next piece of the puzzle. The universe doesn't just belong to scientists. It belongs to everyone who looks up and wonders. So as 3I Atlas fades from the inner solar system, remember what it leaves behind: a question, not a conclusion. Stay curious, stay skeptical, and stay connected. Because new data is coming fast, and every discovery starts with someone paying attention. If you want to keep following this story with verified updates, real imagery, and no hype, subscribe, share your thoughts in the comments, and turn on notifications. The next breakthrough might not come from NASA. It might come from the next person who simply refuses to stop asking why.